Alright, so in the last unit we learned about the nucleus. We looked at different experiments that explained how atoms were structured. And then in this unit we started learning about Bohr's model of the atom, which has electrons existing in different energy levels. We did some experiments with light, we did the flame test lab, and then now we're writing electron configuration. So what this is essentially doing is showing how the electrons are spread out around the atom. Electrons exist in specific locations called orbitals, and there are 4 different types of orbitals. There are s orbitals, p, d, and f. And they all exist within specific subshells, which exist within specific energy levels. In the first energy level, you can see that there is only an s subshell that can hold 2 electrons. So any element that has more than 2 electrons will have to start filling up a higher energy level. For example, hydrogen only has 1 electron in its outer shell. It only has 1 electron, period. And that would go in the first energy level, S subshell, so we'd write this as 1s1. If we were talking about helium, which has 2 electrons, we would say it is 1s2, showing there are 2 electrons in the 1s subshell. When you start the next row on the periodic table, you would have 3 electrons in lithium, and that would have 1 electron occupying the second energy level, S subshell. And we just keep building and so on and so forth. So beryllium would have 2 electrons in that sublevel. Alright? That would be an S2. After we fill up this S subshell, we would have to move over to the P region of the periodic table, showing that the P orbitals are now starting to fill up. So the first element on that section, boron, would have 1 electron in that P subshell. So we would write its configuration. It still has the 1s filled up, the 2s filled up, and now we have 1 electron in the second P subshell. And this will keep filling up. Now, as you can see, carbon has 1 more electron, then you have nitrogen, then you have oxygen, fluorine, and then neon. Now, I'm going to focus on neon for a second because neon is a noble gas, meaning it has a complete highest energy level S and P subshell. And this is what all atoms strive to be like. So atoms gain or lose valence electrons in order to become like a noble gas, such as neon or argon or krypton. So if we look at sodium, for example, sodium wants to have a complete outer shell, like all other atoms. It's called the Octet Rule. And it has the option of either losing this 1 electron in the third energy level, then only having this complete second energy level, or it could gain 7 electrons to become like argon. So it'll take the shortest route, and it would just lose 1 electron, and it would become just like neon. When it does that, the sodium, basically would lose this one. It would become positively charged, because it has 1 more proton than electron now, and we wouldn't have those electrons. So it would have the same electron configuration as neon. If we go in the other direction, and we look at a nonmetal such as fluorine, that is missing 1 electron. It's 1 electron away, rather, from having a complete S and P subshell. So this element will want to gain 1 more electron. When it does that, it'll have 9 protons and 10 electrons, having a charge of -1. And it would no longer just have 5 in its outer shell, it would have 6. Okay? And it would have 8 in its outer shell, making it fulfill the Octet Rule. You can stop.